Hello once again, and now we're going to discuss about if you have a very complicated schematic. There's something called a block diagram for it. A block diagram represents the stages of how a signal goes in and out, or the various stages of a DC and AC signal. So for example, this is referring to, as you can see, an audio signal. Eventually, the audio signal goes to an antenna to be transmitted. So this is a crystal oscillator which has the frequency called a carrier. This is the intelligence, which is the audio that you speak into a microphone. The microphone needs an amplifier. We have to amplify the signal strength when you speak into a microphone. Eventually it goes to an RF amplifier because audio amplifier is audio. 1,000 hertz, 2,000 hertz, up to 10,000 hertz. RF amplifier in this is in the megahertz. So this one over here is audio frequencies, and this is in the megahertz. Now, as you can see over here, there's something called a crystal input, which is a crystal that actually produces the frequency, the high frequency. This one is then carried, the intelligence, the audio is carried on the carrier, the higher frequency, in which is 28 megahertz. So you have 1,000 megahertz being carried on or superimposed on 28 megahertz where it gets transmitted. Fine, this is the block diagram. Let's look more complicated now at the actual diagram and put it into perspective. And then now you'll see how complicated it really is. Let me try to get it. Now here's the diagram. Confusing, right? That's why I said first look at a block diagram. As you can see over here, this is broken up into stages that we just looked at in the block diagram. Now, remember we spoke before in the previous video about values, resistors, capacitors, where they are. Let's just start off with the schematic, simple. You see this? This tells me the value of this capacitor. No, this is not polarized. It's not electrolytic. Could be ceramic, could be anything. This tells me the value of this resistor. This tells me the value of this resistor. This tells me that they both go to, this is a ground, a chassis ground. Tells me that there's a supply. There has to be a DC supply. There has to be a capacitor, and this is polarized. See the plus? That means this capacitor is 100 microfarads. This is not polarized. See the difference? This is plus. They both go to ground. Over here you have a resistor, 2.2K. Again, you have a polarized electrolytic capacitor of 50 microfarads. This is a transistor that we saw, and this is a preamp. This is where the microphone, the signal goes into. We'll get back to that. Then there's an audio amplifier. You have to amplify the signal. So what are we doing over here? This is an amplifier. Of course, an amplifier needs a DC voltage going to it, which is 12 volts. And then you have the same thing, resistors, capacitors. This is electrolytic. We're just identifying the components, the symbols right now, so you know what it's talking about. Then eventually it goes to another resistor. This is only 10 ohms. 0.01. Over here, as you see over here, farads. Over here we had microfarads. Microfarads. See over here? Microfarads. This, farads. Unless it forgot it to say the abbreviation, and it could be microfarads. We don't have farads. We usually have microfarads. So, anyway, like you see over here, 0.001 microfarads. 0.01 microfarads. Could be picofarads. So anyway, there's two things to remember. Let's zoom out. An amplifier. This is a matching transformer. So you see, this is 8 ohms over here. This is 75 ohms. This has higher impedance. Now, this over here is a capacitor with a working voltage, 15 volts. That's the voltage of it. Now, over here, and we're going to go back to that one, is a crystal that I spoke about, 28 megahertz. This is what produces the high frequency. And it goes to something called a transistor, an oscillator, and then this, the type of it, this is the type of it, a type of transistor that you need. This is the serial number. This is the serial number for this one. And so on until you go to the output. Now, there's two things. We have to divide things up. Are you looking at the signal aspect of the diagram, or are you looking at the DC voltages? Two different things. If you're looking at the AC signal line, this is why I put it in blue. Input, outputs. Remember, when you talk about signals, you talk about input, output, input, output. So we start from here. This is the input. How do I know? It says microphone input, high impedance. This is the audio signal when we speak into a microphone. It goes in here, and I put an I to indicate input. Comes out here, O, output. Follow the blue arrows. Goes to a capacitor, right? And then this is the input, pin 1, pin 9, output. So input, output. We're just following the inputs and output. Input here, output at this secondary of this transformer, where this is another amplifier. What's the difference between this? This is an RF amplifier, a higher frequency. So therefore, eventually it goes here and it goes here. If you remember, if we said before, when you see an arrow in a symbol, it means you can change that value. So you can peak this. This one also. When you see this arrow, that means you can change the value. You see from 50 to 150, that's where you can adjust it to. From 50 picofarads to 150 picofarads. Because you can change the value. It's not a set value. This is a set value. This is 20 picofarads. You cannot adjust it. So we figured out one thing. Input, output, input, output, input, output, and goes here and here. That's the audio signal of you speaking. We said we need a carrier to carry it. Where do we start from? Usually in a schematic, we go from left to right for signal. So the signal is produced here, 28 megahertz, into this transistor. Follow the blue, input, output, input, output, and then go over here, input, output. Eventually they join, and that's what you get, audio on top of the RF carrier. That's fine for the signal. As you see over here, I put blue as signal. DC voltage is something else. DC voltage is what's feeding the transistor, what's feeding a chip. Where is it over here? And I apologize for the photography, it's a little tough. 12 volts comes in, feeds this. 12 volts comes in, feeds this. 12 volts comes in, feeds this, and goes to this collector. Notice there's no DC over here feeding this. Only the AC signal is feeding this. This, the arrow, means we can adjust this coil. These are two coils. So, again here, DC, 12 volts. Follow the orange. If you want to measure the DC voltage, I've made a star to show you. A star here means I can measure DC volts. Here I can measure DC volts and make sure 12 volts is coming in. Here I can measure 12 volts. Here I can measure 12 volts. This is a voltage divider. I can measure DC volts here. I can measure DC volts here. I can measure DC volts over here coming from the 12 volts. So therefore, what I want to specify and stress, again, what are we looking for? AC signal? Then we follow inputs, outputs. Start from the left, work your way to the right. What do we want to measure? You can measure, obviously, the signals also, input, output. We want to measure DC voltage. You find the DC of it. Go to over here, measure this. Want to measure the DC? Go over here, measure this. Want the DC over here? Where does it come from? Follow it, and it comes over here. We can measure it over here. And that's how you approach it. Break it into stages. This is called a stage, another stage, another stage, stage. So it looks complicated, but break it up into parts. So if I think I have a problem, let's say the audio is coming in, but nothing is coming out, I don't care about this part. I'll go to the block diagram, find out where is the audio amplifier. The audio amplifier is here. I'll go for input, output, or I'll go for 12 volts, make sure I'm getting 12 volts. That's how you approach it. A second thing about switches, switches can be AC or DC. Like a switch in your home that we were talking about before, a switch for a flashlight. A switch is DC, just like in your car, a switch is DC, right? The battery is DC. In your home, the switch goes to the AC to turn on and off the lights in your house. So switch can be either one. So again, to reiterate, input and output, follow the signal path this way. Looking for DC, find where the DC plus is coming from and follow it this way. I hope this was informative. Thanks for watching. See you next time.